Thermal overload relays are electromechanical devices used to protect a motor against overloads. It consists of a set of indirectly heated bimetallic strips that deforms whenever the current exceeds its limit. Why should we use overload relays? Overload relays are intended to protect motors, controllers, and branch circuit conductors against excessive heating due to prolonged motor overcurrents up to and including locked rotor currents. In spite of being relatively simple and inexpensive, thermal overload relays are very effective in providing motor running overcurrent protection. This is possible because the most vulnerable part of most motors is the winding insulation. This insulation is very susceptible to damage by excessively high temperature. Being a thermal model of a motor, the thermal overload relay will produce a shorter trip time at a higher current. Similarly, in a high ambient temperature, a thermal overload relay will trip at a lower current or vice versa, allowing the motor to be used to its maximum capacity in its particular ambient temperature, if the motor and overload are in the same ambient. Once tripped, the thermal overload relay will not reset until it has cooled, allowing the motor to cool before it can be restarted. Parts of a thermal overload relay. It consists of input and output terminals, current setting knob, reset button, NO/NC contacts, bimetallic strip, and latch arrangement to hold the contacts. All these are enclosed inside a dust-proof casing. Principle of operation of thermal overload relays. The thermal overload relays are three-pole relays with bimetal tripping elements, one per pole. The motor current flows through the bimetal tripping elements and heats them directly and indirectly. In case of an overcurrent, the bimetal elements become bent as a result of the heating. This leads to a release of the relay and a change of the contact's switching position. The contact is used to control the load contactor. The overload relays have a setting scale in amperes, which allows the direct adjusting of the relay without any additional calculation. In compliance with international and national standards, the setting current is the rated current of the motor and not the tripping current. The relays are constructed in a way that they protect themselves in the event of an overload. The overload relay has to be protected against short circuit.
Thanks for watching the video. Don't not forget to like and share.